Hello everybody, thanks for tuning in. This is going to be a short validation example utilizing beam element in Autodesk Inventor um, Nastran product. And I'm using Professional 2022 here, but of course I would expect that you get the same or should get the same results using any other version of the program as well. 2022 is just the latest version that is out. For the problem description, what we're going to work on today, it's a beam guided at one end and fixed at the opposite end. The description is it's a 16-inch long steel beam that has a 1-inch by 1-inch cross section. We're going to give it a 100-pound downward force at the center of the beam. Again, one end completely fixed, the opposite end allowing translation in the direction of that load. The material that we will assign is A36, and then we have our theoretical deflections and moments that we can check once we have it all set up. So I've already inside of Inventor said that I'm going to create a new part. And to create a beam, there's a couple different ways that you can do it. Quite frequently, I'm starting from scratch. So I just create sketches. So just selecting a plane to draw on, I'm going to select the line command, and I'm going to start at the origin, go over a little bit, left click, and I'm going to draw another little line segment, left click again, then hit escape to drop it. So you'll notice what I did there was two different sketch segments. The reason that I did that is because Nastran will convert these sketch segments to beams, and anywhere where you start and stop the sketch line, you will end up with a node in your mesh or a point vertex in your mesh, and you can utilize that to apply your load. So that's why I create a line. We can add our load and then another line segment. We do need to dimension that, of course. 16 inches in total, so 8-inch for each of these sections, these sketch sections, to give me the total 16 inches in length. So there's the 8 and the 8. I'm just going to go ahead and click on Finish Sketch. And there we are with our two 8-inch long sketch lines. I am going to turn off the dimension visibility. The dimensions otherwise can come into Nastran. We don't need to see those when we get into the Nastran environment. So let's go ahead and select Environments, and we're going to select Inventor Nastran. If you've watched any other videos, when you do a solid, the Nastran product automatically sets up for you an idealization for that, and it presumes that you're going to utilize solid elements. Whenever you're dealing with a sketch entity and you bring it over, there is not an idealization that automatically gets set up for you. It's no big deal. You can just click on Idealizations, and what we can do there is then tell it what type of element that we want the sketch line to be. So we don't want solids or shells. In this case, we are going to define it as a line element. And then you have a couple different types of line elements. We're going to choose the beam line element for this case. Over here on the right-hand side, a couple different ways that we can define the cross-sectional properties of this beam. I'm going to use a cross-section input, nice and simple, this particular geometry. So after selecting the cross-section radio button, we'll click the little icon to the right of it. And you can see it's showing me some type of cross-section, and you can enter in the characteristic dimensions. So we have a square section that we're using here. In other words, we can use a box, or excuse me, a bar, and then we can just put in our dimensions there. So it's a 1-inch by 1-inch. And if I'd like, in the lower left-hand corner, I can say draw end A, and that will calculate then for me, display all the properties for our particular cross-section that we're using here. So we can say OK to that. So that has defined this cross-section that we can utilize for our analysis, but we haven't necessarily yet assigned it to anything. What I'm going to do is say associate geometry, and then we can click on our two sketch segments, and now it knows that these sketch segments are using that cross-section. The other thing that we can do right off of this screen, you can get into it independently as well, but we could assign the material while we're in here. So you can see it has some generic material association right now. We'll go ahead and click the icon right here to define a new material. And when that dialog opens up, what we can do is say select material. Of course, you can just type in the numeric values if you'd like, but I'm going to say select material. And then we can choose from one of the libraries. And we're going to choose a steel. It's quite far down the list, steel, and then we need ASTM A36. There we go. And you can see then it gives me the relevant properties. So we can say OK to that. So with this one idealization dialog, we have defined the type of finite element we're going to use. We defined the cross section for the beam. We defined the material, and we defined what entities of our sketch are utilizing all this information. At this point, we are ready to proceed with the rest of the setup, i.e. the constraints, the loads, and the mesh. So we'll say OK to this dialog. If you would like to access it again, you notice it's added itself to the model tree here on the left, so I can go right in and edit the material, or if I go up a level from there, I can double click here to edit the cross section, for instance. So the next thing I'm going to do is generate a mesh. Right now we still have the lines just displayed as sketch entities. You do have to define the cross section and assign the sketch entities to a particular cross section in an element type before you can generate the mesh. If you just came right in from Inventor with these sketch lines and went straight to meshing, it wouldn't know what to mesh because it does not know that those sketch entities are associated to beam elements, for instance. So we would want to do that idealization definition first. So let's go into the mesh settings here. And it's 16 inches long, so I'm going to go with an element size about 1 inch in length, and we do not need parabolic elements. We'll just use linear, and then we'll say generate mesh. And when I do that, you can see now that there are basically a series of line segments that go from light to dark, light, dark. So each one of those is 1 inch in length, and those each are beam elements that comprise the full model. So the next thing I'm going to do is add my constraints. Constraints are nice and simple. It's fixed at one end. So I'll just select the endpoint at one end of the beam, and everything is already checked for making it fixed. So we'll say OK. And then let's go back into constraints. Next, for the opposite end of the beam, go back into constraints. I'm going to select that end. And we want to allow translation in the direction of the load. And the loading I'm going to put along the y-axis. So I'll free up ty here, and we'll say OK. And you notice that the one symbol in the y direction here is a little bit different because that ty, the single arrowhead, is not present, indicating that ty is not constrained. Next, let's go into loads. And we are going to define a force. And it's going to be minus 100 in the y direction. And for the entity, just that node or point right at the center of these beams. We'll say OK. All right, from that point, I think we're all set to run. I do need to give this a name. So this is V8, I think. There we go. And now it's ready to run. All right, so here we are in the results environment. Really fast run, of course. If you look at the node and element count, there's only 17 nodes and 16 elements, so super fast to run. With this model, let's check out some of our results. So the first thing we want to take a look at is our displacement and in the y direction. So for this given setup, I'm getting 7.146 e minus 3. It's negative, so minus 0.007, 146. There we go. And if I hit enter, you can see that from the hand calculation, we're less than 5% different. And then for our moments at the fully fixed end, we expect to see 600. At the partially fixed end, 200. So what we can do for that, what I generally do is I go into the constraints that are here in the browser or the model tree. If I right click on constraint 1, the first constraint that I added was the fully fixed. Maybe I should have assigned them names to make them a little easier to figure out, but I didn't. So, but anyway, let me go ahead and click on SPC summation, and we're taking a look at a moment, and there's my moment about Z. That is 600, so of course that's going to give me 0% difference. And then for the other end, constraint 2, if I do my SPC summation, again, tell it that I want a moment, then that's 200. So again, we'll have 0% difference there, which is all good. So there are a couple different things maybe we could show real quick. Let me close that and let me get back into the results here. We'll click display on that. And so the different types of results, I did it kind of quick before. I went from a stress into a displacement. There are other results here. So there's reaction forces, for instance, and reaction moment. So we could have just selected reaction moment, and we can see that we have a maximum of 600. And then at the other end here, this looks to be about, well, it should be 200, right? So if we go into the probes and hover off the end there, we can see there's our 200. I think I showed that in one of the prior videos that this probe will interpolate depending on where you are. If you want to be more precise, we can go to nodes and we could say query display. Then it's only going to pick up on the individual nodes. So you'll notice it jumps from one point to the next point. So it's just going to the specific nodes on the model. And if we hover over there, again, we should see the 200. Now I need to pan it over here. Okay, there we go. There's the 200 value. So we can do that as well. It might also be of interest if you're working with beam models to see things like the beam diagrams. We can do that as well. I didn't turn on an option before I ran the analysis, but since it runs quick, we'll show you real quick. Let me go in here and I'm going to edit the analysis settings. And in the analysis settings for the outputs, what we can do is check on the force box here. And that way we will get the ability to add on the shear and moment diagrams. So that'll just take a moment to run again. There we go. And now from the pull down menu here, we could take a look at the beam diagrams. And there's beam forces and there's beam moments. So let's take a look at the beam moment end A, and there you can see our maximum of 600. And then of course here we have the 200, positive at the one end of the beam and negative at the other end, depending on how it's rotating about the z-axis. So hopefully that's all useful for you. Thanks for watching. Have a good day.